Okay, as we move into lesson 2, we're going to look at how to divide polynomials. Now we've added, subtracted, and multiplied them, and then even simplified, which is a form of dividing one polynomial over another. But we're going to look at actually dividing them. So what that process is in both long division and synthetic division. Okay, so starting out with long division, remember that when you divide two numbers, and this is recalling, I don't know, 5th grade, you put the top number inside and the bottom number outside. We're going to look at how many times does 12 go into 17, matching our first two digits here. So that goes in once. Then we multiply the top times the outside, and that's 12, and then we subtract. So 5, and then we bring down that next number, so 6. 12 goes into 56 4 times. We multiply that, so we get 56 minus 48. We subtract down, and then we keep repeating this process until this polynomial or this number is completely divided out. Sorry, I can't divide and talk at the same time. So 8, we bring down our 3, 12 goes into 83, 6 times, 12, 72 minus is 9. When there's no more numbers to bring down, that is your remainder. And so we used to put remainder 9. So 146 remainder 9, or 146 and 9/12. And that actually reduces down even further by 3. Okay, so you can check your answer by taking 146 times 12 and then add 9, and you should get 1763. Okay, so your division algorithm, or the formula for this, is to take your P of x over D of x, and then you will have your quotient, your answer function, plus your remainder back over your divisor, which we'll call D of x. And so that's kind of the format that these answers should be in. So let's walk through here. And long division works every single time. It does get a bit tedious, but there's no limitations on it. In synthetic division, we will have some limitations. So we're going to put the x minus 4 on the outside. And then on the inside, we're going to make sure, and we do this on the outside too, that all degrees are counted for. And so we can see here we're missing an x squared term. So when I do this, I'm going to do x cubed plus 0x squared plus 6x plus 5. So you're going to fill a 0 in for any missing terms, because it should count all the way down, right? What this does is it makes sure that our like terms will line up properly. So we're going to look at the first term here and the first term here and say, okay, what can you multiply x by to get x cubed? Well, that's x squared. So now it is above the other x squared here. And then we're going to distribute this. So this multiplies to this and to this. So we get x cubed minus 4x squared. And once again, our like terms are all lined up. And then we subtract down. All right, so watch your signs here. This is negative. This negative becomes positive. This should cancel to 0 every single time. All right. 0 plus 4x squared is 4x squared, and then we bring down our next term. Okay, and then we repeat that process. So we're going, how many times does x go into 4x squared, right? So that's plus 4x. And then we multiply, so we get 4x squared. Those two first terms should match. Minus 16x. And then we subtract. All right, so those two cancel as they should. 6 minus negative 16 is the same as plus 16, so we have 22x. And then we bring down our next term. And so last time here, x goes into 22x 22 times, and then I multiply, so I get 22x minus 88, subtract down, those should cancel, 5 minus negative 88, so 5 plus 98 is 93. And so following our formula up here, I'm going to take my quotient, which is this top one, so x squared plus 4x plus 22, and then add my remainder, which is this number down here, so 93, over my divisor, which is this whole thing that I divided by. And that is my solution. Okay. There are ways to check your answer if you really want to multiply, but not super necessary. Okay, so same thing here, even with a lead coefficient, we're going to make sure that that outside one has 2x squared plus 0x plus 1 when I put it on the outside. And then I'm going to put 4x to the fourth minus 6x cubed plus 12x squared plus 6x plus 1. That one's not missing any on the outside. Okay, I just look at the first two terms, and you can take 4x to the fourth and divide it by 2x squared, and that tells you what goes on the top. All right, so that reduces to 2x squared. We're clear down here if we're matching up our like terms. That's nice. I only have a couple this tells you how many times you're going to end up bringing it down. Okay, so distribute. So I get 4x to the fourth plus 0x cubed plus 2x squared. And then remember, you are subtracting all of that. Okay, so those cancel. That negative 6x cubed just comes down, and that is subtracted, so plus 10x squared. And then I dropped down my next term. Okay, so once again, I look at the front one. I have negative 6x cubed. I'm dividing that by my front term of 2x squared. So this is negative 3, and this would be x. Notice that the terms are lining up here. All right, I distribute, so I get negative 6x cubed. That should always match. Plus 0x minus 3x. Watch your signs here because you are subtracting. And so those cancel. That stays as 10x squared. This is minus negative, and so we end up with plus 9x. Drop down your last one. So this is our last time through. There's nothing else to drop down after this. So same thing, 10x squared divided by 2x squared, or how many times does it go in? It goes in 5 times. And then I multiply, so I get 10x squared plus 0x plus 5. And then I subtract everything, so 9x minus 4. Okay. This represents your remainder because there's nothing else to bring down. So I'm going to write my quotient, so 2x squared minus 3x plus 5, plus my remainder, 9x minus 4, over my original divisor, which is 2x squared plus 1. So no need to put that 0 term in there anymore. Okay, so that's long division, and it is indeed long, but sometimes you have to do it, okay? And this one in particular, the second example, you would have to do it because there's never division by a 2x plus 1 or an x squared or anything. So when you're dividing using synthetic division, you can only use it when you have a linear polynomial with a equal to 1. And that's not to say that you can't manipulate it and get rid of the a and then put it back later on. It's just a really long process to do that. So it's much easier if you just follow this rule, linear polynomial with a equals 1. So no exponents in the denominator and no lead coefficients. All right. To use synthetic division, we're going to set up kind of a reverse division board here. All right. If x plus 5 were equal to 0, then x would equal negative 5. We are going to take this negative 5 and we're going to put it on this outside right here. So negative 5. All right, it's always the opposite of whatever's in the bottom. On the inside, we're going to use our coefficients of this. So we have a 4x squared plus 0x minus 3. All right, so we're just going to take our coefficients, but we need every single term to be counted, including that 0 term. And so on the inside, we do 4, we do a 0, and we do a negative 3. Okay. Now, then you follow a process. We're going to drop down our first number, 4, and then we're going to multiply the outside times the bottom, and then our answer goes up. So negative 5 times 4 is negative 20. And then for this one, we're going to add down. Okay, so 0 plus negative 20 is negative 20. And then we repeat this process. So we multiply, put our answer up. Negative 5 times negative 20 is 100. And then add down, and that's 97. This last number represents your remainder. Okay. This first number is 1 less degree than where you started. So this was a degree of 2. This is just your x term, or a degree of 1. This would then be your constant, and then that is your remainder, because it's going to count down. All right, so my answer to this division problem is 4x minus 20 plus 97 over x plus 5. Okay, so let's do that one more time here. Again, so you're going to set up your reverse grid. We have a 1 on the outside. That's the solution to this denominator. And on the inside, pay attention to what we're starting with. Our degree is 5. All right, so we have a 1, and then we're missing the 4. So we put a 0. That is very important for synthetic division, even more so than with long division. 3, we have a 3. 2, we're missing x squared, so we put a 0. We're missing an x term, so we put another 0, and then we have our constant. So this should count all the way down, 5, 4, 3, 2, 1, nothing, when you're setting it up. Okay, we bring down the first term, multiply, add, multiply, add. multiply, add, multiply, add, multiply, add. Okay, every single time. So it might be helpful to actually write down that process. Okay, and so then you just write your answer, keeping in mind, again, this would be x to the fourth, this will be your remainder, and this should be your constant. Everything in between counts down. So we have x to the fourth plus x to the third plus 4x squared plus 4x plus 4 minus 2 over x minus 1. All right. So make sure you put all of your placeholders. In order for this to work. Okay, with long division, you can at least see them, so you can line them up. Here you can't see your exponents, so you don't line them up. We only use coefficients. And the answer is always 1 less degree. Because we've divided out an x. Okay, so that's your two types of division. Now, using any kind of division, what does it mean if the remainder is 0? Okay, so if you get a remainder of 0, it means the number that you divided by is a 0 or an x-intercept of your function. And so the denominator would also be a factor of your function. Okay. So I can ask the question, and again, see your constant or that number you divided by is a 0 of f of x, so x minus c would then be a factor of f of x. So if we ask the question, is something a factor, you're essentially just dividing to see, do you have a remainder? Does it go in evenly? It's like asking, is 3 a factor of 12? All right, and then is 5 a factor of 12? So you can use whichever type of division you want here. All right, I tend to use, if it fits for synthetic, I almost always use synthetic. I feel like it goes faster, but I have students who just hate this type of division, and I don't care either way. All right, so bring down, multiply, answer up, add, multiply, answer goes up, add, multiply, answer goes up, add. So I have a remainder. So remainder is 26. So no, x minus 3 is not a factor. Okay. All right. So we've had two ways to evaluate. You can evaluate by, if I want to find f of 3 in this previous example, I can take 3 cubed plus 2 times 3 squared minus 3 times 3 minus 10, and I can solve that all the way out. Or you can just use this. F of 3 is equal to 26, the remainder of your problem. Oops, spell that right. Okay, so, and that will always be the case. So your remainder theorem just states that the remainder when a polynomial is divided by x minus a constant is the same as evaluating the function at that constant, which I think is kind of cool. But then you can use synthetic division to evaluate things instead of plugging in every single time, which is sometimes helpful depending on what you're plugging in. It might say use the synthetic division and the remainder theorem to evaluate, it's asking the same thing. So we're going to set this up like we would. We're not going to change the sign here. We're going to leave it the same. So that's where this is a little bit different. Keep in mind, if c is equal to -2, then x plus 2 is equal to 0 is your factor. And so this is why it's -2 outside. So we have 6, 0, 10, 0, 1, 1, keeping in mind our placeholders for x to the 4th and x squared. But the process is the same. We bring down, we multiply, we add, we multiply, we add, we multiply, we add, okay, and we keep this going, so multiply, add, and I should space these out a little bit more. Multiply, and add. And then that's your answer. So P of -2 is equal to -273. And this is how you would show that using synthetic division. Okay, and that's it for this lesson. Have a great night.